Hey guys, Easy Science here. Studying for an exam or just learning for fun? You've come to the right place. Today's topic is pressure. You've probably heard about pressure before, or if experienced it. Let's say you went scuba diving or snorkeling. If you go underwater, you feel your ears popping a bit or hurting. This is because of pressure. The deeper you go underwater, the more pressure. Why is that? Well, I'll explain today. So, basic definition of pressure is a force applied perpendicular over an area where the area is distributed. So, what does this mean? That means if you have a bucket of water and then you apply a force F onto the surface of the water, you applied force onto an area of water. If you only applied force on this area of water, the force would be distributed over there. There'd be more force in this area. But if you distributed over the whole bucket, there'd be less force per capita or per every point. That's why you know what a bed of nails is, right? Yeah, you know what a bed of nails is? Like this guy on there right now. And if you put your hand onto a nail and force pressure onto it, you know what's gonna happen. Your hand, it'll go right through your hand. This is your hand, and you force pressure, the sharp point. Your hand can apply a lot of pressure, and onto this light area, all that pressure would be on that area, and it would go right through your hand. Well, what's happening on a bed of nails, as you see? There are tons of nails. And instead of putting all your body on one nail, you're putting them on hundreds and hundreds of nails. So basically, instead of putting your force over one area, you're putting it over hundreds of area. So it's going to be over divided by 100, even more. That's just a estimate of what it will be. Why I was dividing by 100 is it's not the exact one, but over an area, if there's 100 times more area, then it'd be 100 multiplied by A. If that multiplied by the A, which is the area of one nail, or whatever you're doing. So let me give an example. You're applying, there is a field, or let's do a bed of nails, or even better, on a driveway. Let's say you have a car, or let's say you have a foot, and you're stepping on a driveway, which is 10 meters squared, or let's say 20 meters squared. It's a pretty big driveway, right? Or even better, let's just make a small one, 5 meters squared. But your foot is in length usually 30 centimeters, or at least on average. Let's say the area is 30 centimeters squared. When you step, you're applying all your weight. Let's say you're balancing on one foot on that one point, which is 30 centimeters squared. So you would be F, which is the force you're applying. I'll calculate that later. 30 centimeters squared. You're applying it over that. But let's say you lie down on the asphalt and your body is, let's say, 1 meter squared. Instead of putting so much force on that one point, you're putting it over 1 whole meter. 1 meter squared, which is much more than 30 centimeters squared. Imagine. So as you can see here, the pressure formula is P, pressure, is equal to force, right here, divided by area, just like we were doing. So you get a force, calculating force would be F is equal to mass multiplied by acceleration, and then you get the area, which geometrically. Could be, there's lots of equations for area. Like square area would be a squared. Rectangle would be length multiplied by width. Whatever you want. Or whatever your situation demands you to do. That was a bit eccentrically said, but okay, right here we can basically calculate it with the foot. So let's say your foot was here. Let's say when you started accelerating, it was going at, let's say 30 kilometers an hour. It's pretty fast. And you stopped at 0 because you hit the ground. This can be portrayed by the formula known as, or just the idea of change in velocity and change in time. Basically the slope formula, as I showed you in my other videos. But instead of change in y, which is change in position, divided by change in x, which is slope, because you're seeing how fast it's changing over time, or x, we're looking at velocity, because acceleration is the second derivative, as you might have shown from my other videos. And instead, when you're looking for the first derivative, you do this. But for the second derivative, you have to do it of velocity. So let's do this right now. So change in velocity, or delta v, is going to be 30 kilometers an hour. Here, kilometers an hour minus 0, because when you hit the ground, you stop. Your foot stops. Divided by, how long did it take? Let's see. Let's say the distance between the ground and you was 50 centimeters. We could calculate that right here, how fast it took you. So you were told to time. Your starting time would be 0, because when you start, the timer started, and instantaneously it goes from 0 to whatever you want. And let's calculate how fast it would take right now. So let's convert 30 kilometers an hour to meters per second, or better yet, centimeters per second. So we know that it's 30 kilometers per hour, or it's the same thing as 30 kilometers per 3,600 seconds. That's how many seconds there are in an hour. Now we have to convert 30,000 kilometers to seconds. Or we could do 30 divided by 3,600 kilometers divided by 3,600, because that's how many seconds are in an hour, which would get you, okay, I need a calculator, but which is equal to 0.0083, which continues. We could put a dash on top of it there. So that's kilometers per hour. We have 50 centimeters. That is way less. Okay, we could go from this is a kilometer, and there are 1,000 meters in a kilometer. To get to meters, multiply by 1,000. So 1,000 multiplied by 0.0083 would equal, let's see, 1,000 three zeros. We move to 1, 2, 3, 4 to the right. Or, sorry, 3 to the right. 1, 2, 3. So it would be 8.3 meters per second. Now, to get to centimeters per second, how do we do that? Well, same concept. We know that there are 100 centimeters in a meter. So we multiply by 100. 8.3 meters per second multiplied by 100 centimeters in 1 meter. And we could just cancel out the meters, which would be 8.3 multiplied by 100.3 seconds multiplied by 100 centimeters, which would be 833.333. You just go like that. Centimeters per second. So how long does this take? Okay, we could do 50 divided by, let's name this variable t2 divided by t2 would give us how long it's going to take to get our foot to reach the ground, which would be 0.06 seconds to get to the ground. Okay, that's really high. And then our final time is 0.06 because that's how long it took to get there. When we touched the ground, it stopped the timer. So we get 30 kilometers an hour divided by 0 or per hour, divided by 0.06. Oops. It's going to get us 0.06 here seconds. It's going to get us, okay, or even better, sorry about that, let's rewrite this as 30 centimeters, or 833.3 centimeters per second. So it would be better. We have the same unit per second, which would give us, okay, I don't know, but I'll check. Our acceleration, let's get a drum roll, is, oh my, 13,888.8. Let's just do a 9 right there, or we could just keep it like that. Centimeters per second squared. Now that is pretty good. Now we have our acceleration and our acceleration, which is a. Now we can find the pressure. You guys know the pressure formula, right? You don't? Well, right now I'll show you. Here, I'll move this out of the way because it's getting super annoying. Oh. Okay, force is equal to mass multiplied by acceleration. Let's say, so we have our acceleration. No, actually we don't. This is our acceleration. I'll just keep all of this together. So we have our acceleration, which is this big number. And we still need the mass. The average foot mass or leg mass is, actually, the pressure you're putting is your whole body weight because you're pushing it into the ground. So let's say you weigh 50 kilos. Mass is 50 kilos. kg. So the force is going to be A multiplied by M, which is going to be, and as shown here, a newton is what force is measured in. So when we multiply all of this together, we get, so the force is 694,444.165 newtons. We still haven't found the pressure yet. P is equal to F divided by A. The area was 30 centimeters squared, which would be, here, we'll do P is equal to this multiplied by, or this divided by 30 centimeters squared should equal, oh my, okay, we get to 23,148.1388 of, yeah, pascals. Pascals is what you measure pressure in by the physicist Pascal. I'll do a separate video on him if you want. But pascals are shown here as newtons per area squared, or just area per something squared. In this case, newtons, so Pascal would be to newtons divided by centimeters squared. Anything with form F divided by A. Okay guys, thank you for watching my video. Today you've learned what is pressure, examples of pressure, and how to calculate pressure. So it's going to be very useful in life. Okay, thank you for watching my video. If you enjoyed it, please leave a like and comment if possible. And subscribe if you want to see more videos like these. Easy Science out.